This is the fourth out of 5 videos in section 1, the section on math for chemistry, and this video is going to be dedicated to percentages. Now, percentages is just an application of the algebra for chemistry section, and it's a subject that I know you understand. How do I know that? Because you're high school students and you take exams. And when you take an exam and you get the exam back, the first question you ask is, what is my grade? And if it was a multiple choice test, then it simply becomes the number of correct answers divided by the number of questions multiplied by 100. And that turns out to be a percentage. So if you have 60 questions on the exam and you get 51 of them correct, then you would put 51 over 60, number correct, over the total number of questions, multiply that by 100, and you'd see you get an 85%. The generic equation for percentages is the part divided by the whole times 100 equals the percentage. This is a variation of h divided by I times a constant equals g. 100 is a constant, g is the percentage, h is the part, I is the whole. And if you know any two of the three variables, you can calculate the third. The way to do this is to write out what you know, plug in the values, preferably in the appropriate spot, and solve for the unknown. The total of all of the percentages of the parts in a problem must equal 100%. Easiest way to do this type of stuff is with problems. So let's start with the first problem. There are 535 congressional members in Washington, D.C. 435 of these belong to the House of Representatives. What is the percentage of representatives in Congress? Figure it out, come back, and we'll go over it. Go. 81.3% of the congressmen are representatives. How do we get this? Well, we start with the problem, and then we take the equation. The part divided by the whole times 100 equals the percentage. The whole is the 535 members of Congress, senators and representatives. The part is 435, the number of representatives. The percentage, I don't know. That's what we're looking for. That's the unknown. So now you plug the values into the appropriate spots. 535 into the whole, 435 into the part, multiply that by 100, and you get 81.3%. Let's try another problem. You decide to take your chemistry teacher out for a fancy meal. The total meal comes to $157.28. The service was almost impeccable, so you decide to leave a 19.25% tip. What's the amount of the tip? And you cannot use the tip calculator on your phone. Your phone is broken. Stop, do the calculations, come back and see if you get the correct answer. Go. The correct answer is $30.28. How was this done? Start with the problem. Go to the equation. Part over the whole times 100 equals the percentage. Identify what you know. I know the whole. The whole bill is $157.28. The tip is 19.25%. How much is the tip? That I don't know. That's the part. So you plug the $157.28 into the whole, the 19.25 into the percentage. Now you can do the math to figure out what you have. So you're going to multiply both sides by $157.28, so it cancels on the left, and you're left with the part times 100 equals $3,027.64. Divide both sides by 100, so the part is totally by itself. It's isolated. And you get the part equals $30.2764, but we know we only go to two places. So when you round it, the part is $30.28. That's the amount of the tip. Let's go to problem number 3. You've got a box of Legos. Everybody likes Legos. Your box contains 35 red blocks. You also find out that your box of Legos contains 12.5% red blocks. How many Lego blocks do you have? Stop, figure it out, come back and check, and then we'll go over it. Go. You have 280 blocks in your Lego set. Start with the problem. Go to the equation. The part divided by the whole times 100 equals the percentage. Identify what you know. Well, the part is 35 red blocks. The percentage is 12.5%. The whole is how many blocks? I don't know that. But now, since I know 2 out of the 3 variables, I can calculate the third. So I plug the 35 into the part, the 12.5 into the percentage, and I'm going to solve for the whole. I'm going to divide both sides by 100, and so now the equation looks like this. I need to get the whole above the division line. I need to get it into the numerator. So I multiply both sides by the whole. It cancels on the left. Now we are left with this equation. Divide both sides by 0.125, cancels on the right, and you get 280 blocks equals the whole. One more problem, and then we'll be done. Turns out that room air is made up of nitrogen, oxygen, and a whole bunch of gases. 78% of room air is nitrogen. 1% is the various gases, and so all the rest has to be oxygen. I hand you a balloon that contains 33.3 liters of air. How many liters of oxygen are in the balloon? Stop, figure it out, come back, check the answer, and then we'll go over it. Go. The correct answer is 6.99 liters. How did we do this? Well, we start with the problem. We start with the equation, the part over the whole times 100 equals the percentage. We identify what we know. The whole, it's 33.3 liters. That's how much total air we have. The liters of oxygen will be the part. And the percentage we don't have. So now we have an equation with two variables. So I can't solve it, but we can. Remember, when you add up all of the percentages of the parts, they must equal 100%. So air is made up of nitrogen, various gases, and oxygen. So 100% of the air is made up of 78% nitrogen, 1% various gases, and then whatever the percentage of oxygen is. So 100 minus 78 minus 1 will be the percentage of oxygen. So oxygen must make up 21% of room air. That means that now we can change the problem just a little bit, or the wording, so it looks like this, and now we can plug the values in where they need to go. So the whole is 33.3. The percentage we're interested in is 21%. We still don't know the part, but now we can easily solve for that. Multiply both sides by 33.3 liters, so it cancels out on the left. We're left with this equation. Divide both sides by 100 so that we isolate the part on the left-hand side. The part equals 6.993 liters. And for reasons that I will explain to you in section 2, the more correct answer here is part equals 6.99 liters. So to review this subset of algebra, the equation is the percentage equals the part divided by the whole times 100. If you know any two of the three variables, and the variables will be percentage, part, and whole, you can solve for the third variable. When you total up all of the percentages of the parts, it must equal 100%. The whole equals 100%. And that's the down and dirty of percentages. So now we've completed 4 out of 5 videos, or 80% of the videos in section 1. In the last video, we're going to discuss graphing and the innate beauty of graphs.